Hello, and today we are going to talk about incidence and prevalence. And recapitulating from the last lecture about the measures of disease frequency, we have to say that the measures of disease frequency are measured in static measures and dynamic measures. And today we will mainly focus on the static measures, and we'll talk to the next lecture about the dynamic measures. The static measures are ratios and proportions, and the ratio it's a fraction in which the numerator is not included into the denominator. And the proportion it's a fraction in which the numerator is included in the denominator. While on the other hand, the dynamic measures include rates which have a time component, and that makes them dynamic, and in itself the rates are composed from incidence rates, and we will have them explained in the next lecture. The prevalence is the number of cases in a known population at a designated time and takes into account the pre-existing and the new cases as well. So it does not make a distinction. So in the numerator are included all cases, either old, either new. The time frame of this, it could be a point prevalence or a period prevalence. The analogy would be that in a film strip, you have a snapshot of one slide and you see what's happening into that time, and that's the point prevalence. What are the cases in that period? Well, when we say period prevalence, it's a couple of slides, so it's the number of cases that are known to have occurred into that specific period of time. So for analogy with the filming, it's a couple of slides we sum up. So one example would be the annual prevalence, which is the sum of all point prevalences at the beginning of the period and the number of new cases that occurred during the period of the study. There is also, let's say, lifetime prevalence, which is the number of all animals which are known to have had a disease in at least a part of their life. And the formula to calculate this is the number of individuals having a disease at a point in time over the number of animals in the population at risk at the same point in time. So that's how it's calculated. For practical purposes in veterinary epidemiology, we have different levels of prevalence. So we have animal level prevalence, which expresses the proportion of animals that possess the disease of interest. However, since animals are aggregated, let's say in herds or in farms, or villages, so it depends by the level of the aggregation, we would have different prevalence levels, let's say within herd prevalence, when all the infected animals are in the same herd or in the same farm or in the same village. And then we have between herd prevalence, which is expressing the proportion of all herds which one or more animals is affected by the disease. And this could be also in between villages, or depends by the unit of aggregation we choose. However, the between herd prevalence is very useful in describing the spatial distribution of the disease. And factors which determine the level of within herd and in between herd prevalences are different. So when we do a study, we might have different figures from within herd and between herd prevalence. So because different factors are in play, the contact rate within herd, let's say it's higher, but the contact rate between two different herds is lower, and so on. So we might have always the different figures of the prevalence, even though we are studying the same disease and in the same population into a district or into a country, we might have still differences in this because of the factors involved in. The incidence, on the other hand, is the number of new cases which occur into a population over a specified period of time. And there are two major keywords here: new cases and time over which the new cases do occur. So this second term makes the incidence rate and makes it much more dynamic in compared to the prevalence. Today we are going to focus mainly on cumulative incidence, and we'll talk into another lecture about the incidence rate. Cumulative incidence, which is also known as incidence risk or incidence proportion or attack rate, so these are all valid names to call cumulative incidence. It's a proportion of non-diseased individuals at the beginning of the study period, and that becomes diseased during the time we follow them up. And the calculation to do the cumulative incidence is number of animals that become diseased during a particular period over the number of healthy individuals in the population at the beginning of that period. And of course this can be multiplied by a multiplier of choice, let's say for 1,000 animals, so incidence of 1,000 animals, of 100,000 animals, over 1,000,000 of animals. So it depends by the scale of the population we are studying, and then we implement this multiplier to give more meaning. However, the risk of a new disease occurrence is quantified using this cumulative incidence or incidence risk, and it's interpreted as the individual risk of an animal, individual animal risk of contacting or developing the disease within the follow-up period of the study. However, animals must be disease-free at the beginning of the follow-up period and to be included in the numerator or denominator for this calculation. So the two distinctions between prevalence and cumulative incidence are that the prevalence counts both old and new cases. So whatever has existed as a case within the time frame of the study or the point in time we are checking, and whatever has developed, it's counted. While in the incidence, the counts only refer to the new cases occurring during the follow-up period, so during the study period or the period we are investigating. The prevalence, it's a proportion, and being so, it measures the disease burden. So it's telling us how much of a disease is out there. And it's a very useful tool, especially for policy making, because it tells how much disease is there. Too much, is there too little? Do we need to deploy too many resources to control it, or do we deploy less resources? Because depending on the magnitude of the problem, we adapt our policies. So it's, let's say, the number of vaccinations needed, or the numbers of vets involved, or the other resources. So it's very useful parameter for policy making. On the other hand, incidence, it's a rate and measures the risk of a disease, and it tells us how fast is a disease spreading into a population. So the speed of the disease that it's occurring, and it's happening into the population, and that's, in essence, it's a measure of risk. And the faster the disease it's occurring into the population, the riskier is for the animals to contract the disease. So let's call in again our old good friend, the Georgian Shepherd, and he has an issue with mastitis in his sheep, and which is mostly common in ewes raising multiple lambs or with high milk production. And this guy, it's a very professional shepherd and has very good producing animals, with sheep having twins and having high production levels of milk. So in order to quantify the problem he has with the mastitis, we should check a bit what's the number of population at risk of sheep, and because mastitis develops only in lactating sheep, all the others are not eligible to get the disease. So let's count first the flock and define the population at risk, and pay attention that counting sheep, it has an inherited risk of falling asleep during the job, so we don't want that, so be focused on countings. So from the photos we saw that the shepherd had a goat, and we have that in black here, and that's the first thing to eliminate. Even though goats gets the mastitis, we are not interested into the goats. The focus is on sheep. And then he had 2 rams, and of course they don't develop the mastitis because they don't have a udder, so they cannot. And then he had 13 lambs, and they of course might die because of taking infected milk from use with clinical mastitis, but still they are not affected themselves. And then he had 10 sheep with mastitis, or not with mastitis, but potentially getting mastitis. So the population at risk is this 10 sheep which might get infected with mastitis. And so this is the whole population, and we stratified. It's not a difficult job, but still we need to be focused and defining well what's the population of risk at risk, and what are the animals that can develop the disease or the health issue of interest for our study. So again, summarizing, we have 10 lambing sheep, which are the population at risk. We have 2 rams, 13 lambs, and 1 goat. So we will have to study his flock for a period of 12 months. So this will be the study period, and it will be the follow-up of whatever is happening in terms of disease occurrence in the Georgian Shepherd flock. And then we have the 10 animals on one side, and then we have the months, and we follow up. And then what we are interested in is that a disease starts counting when the onset of the disease started, and then the animals are removed from being at risk or having the disease when they are recovered, so or cured, and then also may die, but in this case it's a treatable disease, so they get cured, and we assume they don't get reinfected. So that's also an assumption we are making for these animals. So it has a start of a disease and an end of a disease. And we see here all the other animals, so A, B, C, D, and so on. So in the whole study period, to define the cumulative incidence, we have to count only the new cases, because the incidence deals with the new cases only. And if we see a bit the seasonality of the disease, it's mainly occurring in the springtime, in the early part of the year, which is also the part where the climate is not very good, and it's also the lactating period. And we count and we say that animal A is within the time frame, animal B is the same, animal C is the same. However, animal D, the fourth in the row, has the onset of the disease before the study period begins. It's before the follow-up. So we don't count this as a new case, because that was an existing case. And then the animal E has the onset of the disease within the study period, even though it did not recover within the study period, so it counts, the E counts. Then we have animal F, which is during this study contracted the disease after the study, so it's not part of it, was sick the next year, not this year, and so it doesn't count, it's not a new case for this period. And then animal G had the disease before this period and recovered before the study starts. So it doesn't count as a new case as well. So we have also animal H, I, and J, which never developed the disease, so they are not cases. So in total we have 4 new cases, animal A, B, C, and E. And this forms our numerator. When we check a bit the denominator, we see that we have 8 animals, and then it's the animal A, B, C, the D doesn't count. The E has a risk before, so it was at risk and then developed the disease. F as well. G it's not counted because he is not anymore, that sheep is not anymore at risk because it has been recovered from the disease. And then the last 3 ones are at risk of developing the disease because they might contract the disease. So in total we have 8 animals at risk, and so the cumulative incidence is 0.5 animals per 12-month period. Let's see a bit the prevalence now. And the prevalence, as we said, it's a snapshot in time. And then we choose, let's say, the month of May. And during the month of May we start all cases, we count all cases in that period, and we say it's animal A, B, C, and E, again for cases. Even though for the May, a new case it's only animal E, and all A, B, C are pre-existing cases for the time period we are counting. And this 4 forms again our numerator. If we check what's the population to be included into the denominator, we again have 8 animals, and it's the A, B, C, E, F, and all H, I, and J. So all these other all the last 3 remaining animals are countable as well, but animal D could not be counted because it recovered before the study period, and the animal G also recovered before the momentum we are taking the snapshot. So we have as a prevalence 50% of animals got the mastitis. However, if we think and then we change the time period where we do the snapshot in time, and we count, let's say, from February, we would have two cases, and then we would have almost 9 animals as a population to be included into the denominator. And if we assume the whole year, then what would be the annual prevalence? And that's, I'm leaving that to you to follow through and there exercise yourself with different time periods. And in the link in the description below, we will have a self-assessment quiz and exercises for you to check more your knowledge on incidence and prevalence. In the next talk, we are going to talk about the incidence rate, and then we'll check other rates and measures of disease frequency. Till then, be safe and see you next time. Thank you.